welcome back to the channel. Tonight we are going to be working on this, let's see, it's a 2018 Kia Forte. It's got a 2.0 liter 4-cylinder, and the customer's concern is that it's running rough, making some sort of kind of rattle noise, and obviously check engine light. It does have some codes in there, and they are related to timing, particularly the exhaust side, and I'll get you a shot of that. Also a shot of how it runs, and kind of go through some steps and a way that we can approach to try to figure out what's causing this running issue and check engine light. I have not worked on one of these yet, but they look similar to some of the other generations. But again, we will dive in and see what we can find. There's a shot of the trouble codes. Obviously, we are going to be concerned with these two, the 0014, 0017, and basically the 14 is describing that the exhaust is over advanced, and with that we are getting obviously some misfires because it does not run the best, and so those we're not going to worry about right now. We are mainly going to concentrate on what's causing these timing codes to come up. Okay, so that was a shot of how it runs. I still not have turned it off. Let's see if we can, just out of curiosity, get some data PIDs. So basically these are going to be like your actual and desired. That's desired. That's desired. These are actual. There's your intake and there's your exhaust. This one is off currently. And almost also, I mean, right now it's not wanting any movement on the exhaust, so that's why we're not seeing possibly any change. But maybe I'll drive it, but this is just quick scan data, I guess. Kind of verifying through the scanner that exhaust is not currently matching the desired. So I think from here on out we're gonna break out the scope and see what we can find. Okay, so the first test that I want to do is do a cranking, no start, and monitor a few of some of the important things. I've got relative compression, amp clamp there, synced on coil 1, tapped into crank sensor, then I've got intake cam and exhaust cam. So what I want to do is crank it for a long time. This is going to let me check and see what the current, basically base timing, where the chain itself is set up, along with, I guess, the cam positions. We're going to be able to try to reference that with the crank. Also see where ignition is compared to the relative compression. And I want to just crank it, and I also want to see if the intake and or exhaust, in this case particularly, cam moves during cranking, and that'll give me some idea of potential variable cam timing issues. So I am set up. I've got the injectors all unplugged. Scope is running, and please do forgive me. I am a little under the weather, so a little bit nasally. Nonetheless, let's get this cranking, see what it looks like. Okay, I should have had a jump box. But this will give us a good start. Okay, so here is that initial capture. And I was able to find an example. This is from actual factory information. But the only thing that I was kind of concerned with, which I could still check or was gonna check, is that this is stated to be during idle. And I was a little concerned about possible variable cam timing coming into play at idle, but I think it's still a good usable comparison to what we've got here. So the first thing that I want to show you, this is the crank. This is the intake. There we go. And this is the exhaust. If we look at their reference point for the intake, it is 13.5 teeth for the uprise there after the gap. And so here is that gap. I've counted 13.5 teeth where that ruler is. And we are kind of close. Realistically, possibly a tooth off, but the intake is there. If we look at the gap compared to the exhaust, looks like to be close to 6 teeth from the gap to the uprise. And clearly we can all see that the uprise is right in the gap area for the exhaust. So what that tells us is that just cranking without any idling and oil pressure coming into play or variable cam timing, duty control, none of that. That is telling us that the exhaust, just with straight up timing, is off. It is actually advanced. And so, if at its cranking steady state, the exhaust timing is off, that means that the cam position has rotated to a spot that it's not supposed to. Now the next thing I want to look at, and I can check on the waveform, is if the cam position during cranking moves or changes positions at all or stays steadily fixed in that advanced position. And that'll tell me if there's a problem with the solenoid or possible phaser. So in order to determine that, I'll show you here at what I look at, but quickly, because I just jumped right to the cam signals, something that can be a little bit interesting is let's look at our relative with our ignition sync. So there's ignition sync, ignition sync. So it's 1, 3, 4, 2, back to 1. Those are our cylinders. And it is firing right at the peak point of top dead center compression for cylinder 1. We are synced on cylinder 1, ignition. So the sparking is being timed correctly, but we know our exhaust cam is off time currently. So back to how I try to determine if that cam is moving. Very early on in the waveform capture of beginning cranking, I'll start to look at that exhaust cam. And I want to look at that point and where it lands, if it's any different from where the cranking event ends. So this is the very beginning point. That exhaust cam seems to be right there close to the gap. Let's actually take a look. So it's actually a little bit off to the right. Let's just keep that in mind. And the reason why I do this, I've got another video where I tested this, or in this way, and I was able to find that the cam was moving. So if I go forward, so that is now in the gap position. Let me, let's go back to that very first one again, just to, so it is not in the gap position. So we've got some movement, but, we are just statically, cranking it. And so let's just continue looking, see if we get a greater, crazier movement. There it is again. Looks like the same point. Again, about the same point. And so I'll continue this. And I will go to the end of the capture to see if at that point there was any greater movement than what I'm seeing. So far it looks to be staying about the same. So here's the end, and actually there's that point. And it looks to be the same. So that very first two segments during the first cranking, I'm not too concerned. So that's why I checked multiple points, and hopefully I'll be able to link that other video. If you see, I know that we started to the right of the gap and then we moved into the gap, but what you want to see is a greater movement of the cam if we're trying to determine a variable component issue like the control solenoid or the phaser being the cause of incorrectly locating the cam currently. But the fact that there is no other movement other than that, yes, first initial cranking, and it has stayed there during the whole cranking event, it's probably looking like it is going to be truly a chain, like loose chain or jumped chain issue. Possibly more and more of a jumped chain issue, not so much loose, because it's staying steady. Again, if the control solenoid was stuck in a certain position or direction and oil flow could flow when it shouldn't, it can move the cam phaser, and that's again what I've seen before. It'll move it from the starting point to, depending how far, probably 25 degrees or so, and possibly even like bounce back and forth, and not just, it just won't be steady. Again, if a phaser is failed, I think most likely it should and would do the same. Possibly loose chain, I would maybe think you might see some bouncing back and forth of its current location. This one, just gut feeling, and I could be wrong, and just what I'm seeing, that from the beginning to end, it's pretty much at that same single point. I'm wondering if it has jumped the teeth and is now steady located where it's at, but it's in an incorrect place and position, and possibly could be from, like a worn out tensioner, let it just jump, and now it's at where it's at. One other thing to just show you, to bring up some sort of numbers to get an idea. I was just curious to possibly looking to see how far off the exhaust cam is, again, in its base timing point. I've got my degree markers put up. These rulers will give us degree numbers. So I've set this one here at the point where, according to this printed waveform, where the exhaust should be, again, about 6 teeth past the gap. Then bring the second one, compare the difference, and it looks like about 27 degrees of advancement is where we supposedly are at right now. Now, normally, if you watch my channel and or follow me or my diagnostic processes, I'd like to dive pretty deep. At this point, possibly, and I've shown again in other testings, I would probably normally would go to the solenoid, apply voltage, but it would depend on which direction the activation of the variable cam timing is going to move that exhaust. If it advances it, so right now, just being that currently we are almost 30 degrees advanced, I think for the moment, until I bring up service information, if I can find and see which way it moves it, because I thought I saw something on as far as the exhaust starting point. I'm not going to go that route, but I do still want to look at some other information. Now, we know 100% we've got to open this up, look at the timing components, and do some timing work. We know that's where we're going. Undeniable, based off the symptoms, how it runs, the noises it makes, the trouble codes it has, and now the verification that we are seeing. We're definitely going in there. But again, if you guys know me, I like to dabble and learn a little bit. So I want to monitor a couple other things because we're going to have a before and after. And I want to see what this looks like with that exhaust advanced so much. So I'm going to go in cylinder, look at that, and I think I'm going to look at intake and exhaust pulses because you know that there's going to be a difference. And so I just want to see what those look like now and the in cylinder. Okay, so I am set up and still again just cranking only. Okay, and now I'm actually going to run the vehicle with all the in-cylinder and intake exhaust and cam sensors. Okay, so after some digging on service info, the exhaust starts off fully advanced, and so when it's activated, it'll move to the retard position. So we should be safe to activate it, see if it'll retard from its way over advanced point right now. We got two pigtails on the solenoid. We will activate it while it's running, and then we'll watch the scope to see if it'll advance. That'll tell us if the phaser is in good working condition. Okay, everything is off and apart, obviously, and the timing marks are here up front. The crank is set to, they want this pin straight up, and then the two, this line and this line should be close, basically facing each other. It's hard here on camera to show you, but they're not off as much as we were expecting based on how advanced the exhaust was coming out to be. So on the face end, they look not that far off. But what we noticed, first of all, it looks like this gear and the cam are newer in color, as you can tell there and there. Maybe some work was done on the exhaust side beforehand, but the other thing we noticed is this dot and that dot. This dot seems to be more forward compared to this one. It's more straight up in the middle. We're wondering if the face is sort of lined up compared to the actual cam position, and we're wondering if there's an issue in this connection here. We're going to take this all apart, take this gear off, and see if there's an issue there. Okay, just follow up. Chain tensioner guides are off. We broke this bolt loose only. It's broken loose. And there is, never mind the in and out, just the fact that there's rotation and it feels a little notchy. This is the intake, so something that we are noticing. And sure enough, a broken or sheared, looks like locating dowel that's dug into the gear and is missing. So that should be like a protruding knob dowel pin that locates the cam gear in one place like this, and then from there the phaser will move the cam jointly with the phaser. But right now, someone, when they were in there, looks like did not install this properly. Okay, so I've got the cam caps out, in the middle of replacing the camshaft, and just showing you new cam phaser and camshaft. I got confused for a minute. I didn't see the locating dowel, but I guess it comes pressed into the gear, not the camshaft. So we'll be sure to locate these properly and get them installed. Okay, just wanted to show before I lock this down. So I've got it installed. The bolt is loose, but with that dowel in the hole, it properly is secured and won't rotate. That's how it should be installed before torquing it. So I just got it running after cranking it for a while, build up oil pressure. I know I didn't get it on camera, forgive me, but just quickly checking the data PIDs. So obviously that was good before, but the exhaust is right on point where it needs to be. So looks like this will be good from here on out. Okay, so this is a shot of the cranking no start with the end cylinder, and I've got a few channels going on. Obviously we know this is going to be the crank, cam and cam. We've got exhaust, intake, and I've got ignition in the green, and I think unfortunately I used the end cylinder for, it's the gray channel, and it's very hard, at least for me here, to get it to come out pretty much a good visual color. I think it's too hard here on camera, but just follow my pen. We won't spend too much time on it because of it's hard to see. So we've got top dead center, comes up, comes down. There's the exhaust valve. It's a deep pocket, comes up, and then there's an uprise there, comes down, and then intake, and then back to compression. This is the big dead giveaway. It is an uprise because the exhaust valve closes early during the exhaust stroke. So just to try to show a little bit easier, but not too sure. Let's see if we zoom in there. So there, the exhaust valve opens there, closes there when the piston is in its upward stroke. That's why when it closes, both valves are closed and we build basically positive high pressure. And then it's all due to the exhaust cam being advanced. So it's off to the left. Everything is happening more to the left. So it opened way early and it closes way early, and we make that high pressure. Maybe quickly here we'll get some numbers. So it opened at about, that's so 71 degrees before bottom dead center. And since we can actually measure it, say somewhere in that range, that says 51 before top dead center. So keep those in mind. What was it, 71, 51? And then actually for total kind of duration, it's right at 200. Okay, and so this is the in cylinder of when we cranked it, started, and idled. And then here I actually revved it and held the revs. Again, my apologies. The in cylinder is in the gray. It's basically the more important channel, and I ended up capturing it in a bad color for a camera. So we'll look at it quickly here. Get some of these out of the way. So again, even at idle, oh, that's terrible there. Just follow me here. We've got compression, comes down, and then there's the high peak, comes down, intake, and then compression there. So again, we are advanced at idle, and that's why it runs so bad, because pressures are just not the way they're supposed to be. And this capture here is actually when I activated the solenoid for the exhaust variable cam timing. And these points you see with gaps, that is when I activated. So again, apologize, we are in gray, but let's see, we are able to see a change. Okay, so here we can see a little bit clearer. So this here is, I was capturing the amperage of the solenoid. So when it's up high, the solenoid, I actually grounded it, so we have current flow. And then when I let off, it drops, and so on and so forth. But here's compression, here's compression. There's that high peak because exhaust valve closes early. If you look here, that's when we had activated and then we delayed and retarded the exhaust timing. Once we let off, even though we had a rising ramp when we shouldn't, compare it to, see, after we let off, it starts going up, 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 up. That's because the cam is going back to what its home place now, which is very advanced, and we are seeing that happen because that rise in pressure is happening because the cam's advancing further and further, allowing more pressure to be built up the more it advances, and so we get that high rise right there. But it actually idled and sounded better when it was delayed and retarded when we activated the solenoid, and you can tell because that pressure came down. And just to point out another section, I'll zoom in here in a minute, but just to show, and hopefully we can see it a little bit clear, here are those high points in the middle of the compression peaks. And purple again, it comes up, amperage goes up, and the solenoid gets activated. Look at that middle, basically high peak, how it just comes down. And at this point, it's after a few times of hitting the solenoid, look how much more it retarded to the point where we have no peaks in the exhaust ramp there. So let's just get down there and see. So it almost makes it look like a normal idling in cylinder. That's why it basically literally did run and idle way better when I would hit the solenoid, because, and we can see it here in this waveform when we activate it. Since activation of the solenoid on this vehicle, does retard the exhaust, because it's so advanced, when we retard it, we get it to a good idling point or a good cam position for breathing that it runs better. Now, my whole point on trying to do what I was doing was to try to identify a failed part or component so we know, what to order, or just learning and studying and so on and so forth. So when I was doing this, and the reason why I was doing this was to see if the phaser was in good condition and if it was possibly, again, just a jump tooth situation. This told me and shows me, and we can see that the phaser is working properly. Clearly, we have a change of pressure in that section. We are moving the cam. We're moving it from a very far advanced position back to a more normal retarded position. But the important thing was that we are moving it. So the phaser's good, the solenoid's good, the cam for some reason is in a wrong position. Now, this is towards the end of the video, which we clearly saw that the pin and stuff were damaged. So whoever installed it or whatever happened, or just over time it shifted and broke, who knows. But even at the shifted wrong position, when we provide oil to it, the phaser still is able to do its job, and which is move the cam. And but clearly, with the broken pin, we cannot use that phaser. So everything had to be new again, despite the situation. So this was all part of the testing I was doing to try to find out what was needed, and we clearly see a difference there.